Okay, welcome back again. Let's continue solving problems in relation to our topic, resultants of force systems. Okay. So, recap lang natin ang what we have been doing is that we are converting yung system of forces into either a force coupled system or a single force located at uh, a certain point along the structure or the rigid body. Yeah. Okay, so let's solve this problem. Replace the loading system by an equivalent resultant force and specify where I should say, the resultant's line of action intersects the beam measured from point O. So this is point O, this is the beam, subjected by three vertical forces directed downwards. Okay, so i-convert lang natin to into a single force located at a certain distance from point O. No? So it's our beam. This point O. So this would be the resultant R. Located at a certain distance x. Let's say x from point O. So first we need to solve for R. The resultant, of course, is just the sum of the vertical forces. So the resultant natin is just equal to, so summation of forces along the x direction. Wala namang forces along the horizontal direction. So definitely that is 0. No? And all of the forces are on the vertical axis. So they are all directed downwards. So the resultant is simply equal to the sum of the three. That is 500 pounds plus 250 pounds plus 500 pounds. Okay, all directed downwards. So the resultant is equal to, ano yung resultant natin? Sundo naman. Meron pa rin answer dito. That's 1,250 pounds. So that is the resultant, no, all directed downwards. Okay. Although additive yung ginawa ko dito, but the direction would be downwards. Okay. So next is to solve for the location of this resultant along the length of the beam from point O. So this is point O. So again, we are going to use the principle of moments. So yung principle of moments, dapat yung moment ng R about point O should be equal to the sum of the moments of these three forces about point O. No? Is it visible dun sa ating, yeah. So the moment of R at point O, about point O, is equal to the summation of moments of these three individual forces about point O also. Okay? So we know R. So a point O natin is nandito, no? Ito yung point O natin. So R creates a clockwise moment about point O. So obviously that would rotate clockwise direction. So so positive yun, positive, of course. R here is 1,250 pounds times x distance from point O. That should be equal to the sum of the moments of these three forces about point O. So let's start with the 500. Ito, 500 creates a clockwise moment about point O. So that's positive 500 pounds times a moment arm of 500 pounds about point O is 3 feet. Oh, no. 250 pounds, again, clockwise. Yung rotation niya about point O, so that's positive 250 pounds. Since moment arm from point O is 6 feet, 3 plus 3. And lastly, the moment of this force about point O Again, that's clockwise, so it's positive. Okay. So take note, you can use yung sign convention sa module natin. Sign convention sa module is counterclockwise positive. Pero sa video natin, clockwise positive. You can use, you can use any of the two conventions, but just be consistent na lang. No? Consistent sa paggamit ng sign convention. Anyway, we will be arriving at the same result din naman or answer. Alright? So, ano yun? 500 pounds times the moment arm about O, that's 9 feet. Okay? So, we can now solve for the unknown distance x here. This is equivalent to 6 feet. Ayan. So, yan. So, we have the resultant and it should be located 6 feet from point O. No? Para the same yung effect. Para equal yung system natin. Equal. Okay? So, pag equal yung resultant, okay, yun na. Resultant and then yung moment about a certain point. Ayan. Okay? So, that is how we solve. That's how we solve for this problem. So, let's proceed to the next and perhaps the last example for this particular topic.